Good afternoon, and thank you all for joining us for our webinar today as we take a look at an introduction to Visual Components 3D factory simulation. We are joined today by CAD Micro's VP of Sales and Managing Partner, Chris Watkinson, and Visual Components Director of Business Development, Graham Wloch. Before I hand things over to Chris to kick us off, there are a couple of quick housekeeping items to mention. First, as usual, we'll save a few minutes at the end of today's session for a question and answer period. Feel free to type your questions into the GoToWebinar panel as they come up, and we'll do our best to get to them all at the end of today's webinar. The webinar will be recorded, and we'll be sending you the recording via email tomorrow. So if any questions do arise afterwards, you can feel free to respond to that email, and we'll be in touch shortly. All right, without further ado, I will pass things over to Chris to get us started.
Thanks, Sarah. I'm with CAD Micro Solutions. I'm VP of Sales and Managing Partner. I'm just going to give a quick introduction to CAD Micro and how Visual Components fits into the ecosystem for innovation that CAD Micro is bringing to Canada. So what is Visual Components? I mean, it's a big product. There's a lot of different customers globally. It's fundamentally, it's a 3D factory layout tool. It's an animator, but it's much more than that. It's a discrete event simulation and robotics programming and simulation tool on one platform. People use it as their application development toolkit. It has Python. Some people simulate machining or painting or other processes. It has a PLC validation application. People use it in controls. People also use it for ergonomics. It's so big that it really is the ultimate digital twin product. If you would like to create a digital version of your manufacturing process or a work cell or any other manufacturing application, you really should be looking at Visual Components to improve the way that you're bringing your products to market. A little bit about CAD Micro, if you're not familiar with us. We're a Canadian provider of engineering and manufacturing technology. We're coast to coast. We're 100% Canadian owned. We have offices in Vancouver, Calgary, Cambridge, Toronto, and Montreal. We've been in business for more than 37 years, and we're about 60 people. And what makes us different is the way that we bring technology to our customers. We challenge their existing processes. We look for opportunities to adopt new technology to address their critical business issues. And we work with them collaboratively to deliver the solution. And we back that up by the CAD Micro customer commitment. When you look at the different areas of Industry 4.0, and Visual Components is a great one, CAD Micro is bringing 5 teams that enhance one another and cross-pollinate one another to enable innovation in our customers. The first one is design software built on the SolidWorks ecosystem. We also have advanced manufacturing solutions like 3D printing and CNC machining, and Visual Components has a role to play in advanced manufacturing. Also advanced simulation. I mean, Visual Components can be seen as a simulation tool because you're getting at where the bottlenecks, what's the cycle time, statistically, what's the throughput going to be if I put in, a Monte Carlo simulation or a normal distribution or chance into my simulation. You can do validation on simulations that you couldn't do with linear programming or couldn't do using a solver in Excel. We also get involved in 3D scanning and metrology. Again, Visual Components has a role to play because you can bring in factory layouts that you've scanned with like a LiDAR scanner into the tool. And the newest one is our digital experiences, or what some people call augmented, virtual, or extended reality. Visual Components has a visual reality component to it where you can take your 3D factory simulation and put on a headset and really get into an immersive experience where you're validating the digital twin before you're actually producing anything to make sure that you have the right parameters, the right ergonomics, and that things will fit in the real world before they're built. The solutions that we bring to the market, whether it's SolidWorks or Visual Components or whatever it is, have 3 things in common. They're all professional quality, they're easy to use, and they're affordable for companies in Canada. We work in 11 different industries, everything from marine and life sciences to industrial equipment, high technology, all of the main industries in Canada, CAD Micro has customers in that are using products like SolidWorks or Visual Components or 3D printers. And all sorts of different organizations, whether it's government or military or SMEs or sole proprietorships or Fortune 500 companies. What we think separates us from some of the other companies like us in our space is that everything that we do, we back by the CAD Micro customer commitment. It's our Canadian value system that if we sell something to you and we make a promise, we want to make sure that you're getting what you expected. And so you have our commitment all the way from ownership throughout our directors and managers to our frontline tech support staff, that if there's any challenge during the implementation or anything that isn't quite working 100% as it was promised, that you have our commitment that we're going to fix it and we're going to work with you and stick it out with you so that you get exactly what you thought you were going to get. And that really allows companies and our customers to have the confidence to adopt new technology like visual components. You know, everybody's been burnt by buying the wrong piece of software in the past. So when we make this commitment and they say, hey, if I invest in something like visual components for factory simulation, that CAD Micro is going to stick with us for the training and implementation phase and make sure that we're a successful user. We have a number of different extended reality solutions at CAD Micro in our digital reality group. We have an AEC validation tool called Fuser, which is bidirectionally associated with something like Revit. We have an augmented and virtual reality toolkit from Theorem. Obviously, SolidWorks Visualize is a digital experiences tool. You know, there's SolidWorks Composer, there's the things on the 3D Experience platform. But in terms of a true digital twin, visual components, factory simulation, and robotics really stands alone. So I'd like to turn things over now to Graham Wloch. He's going to give us about a half an hour live demo of the product and hopefully whet your appetite as to what's possible with this amazing factory simulation tool. Graham?
All right, thank you so much. Let me find out where I'm sharing. Okay, how about that?
Looks good.
All right, hey, so again, thanks everybody for showing up. Like Chris said, I'm gonna kind of run you through some of the real basics about us, what place we have in industry and in your process. And then, you know, once we get past all that boring stuff, we'll go ahead and jump into the software. We'll show you the evolution of a cell, what you can do with software, what it can help you achieve, and some of the different kinds of insights that it can actually give you. Let's go ahead, jump. So visual components, our purpose is to empower companies to improve production in a sustainable way, right? You know, for years and years and years, it was, you know, go to an integrator, rely on somebody else, bring in a consultant, have some external person come in and tell you how to do your job. We believe through simulation and by providing the tool for customers, it allows them to own their own process. They can leverage their expertise, their knowledge, their history, their understanding of their environment, and really not just hit a production goal, but continue to go above and beyond that and continue to optimize that process, be it something that's existing, be it something that's new, be it something that's being consolidated, you know, whatever the case may be. It's a little bit about us. This is as of last year. You can see we've got a lot of licenses. This is a European format, so that's not just 27 licenses, but many, many more. We've averaged some pretty outstanding growth. You can see by the chart, and that's a little bit of a breakdown of who we are and where we are. The main office, obviously, being in Finland. You notice on the chart on the right, 2016 was when we introduced our 4.0 platform, and the next 3 years we saw, you know, considerable growth as we brought a product that began to address more and more customer needs. 2020, we all know what happened there. while Visual Components was down overall, I can tell you the Americas set a record that year for sales and growth. As more and more things come up, as the way business is being done forced us to look for new solutions. Visual Components was there to again provide a tool to people that wanted to leverage technology and what's available to them in order to continue to grow and to achieve their goals. And then obviously you see the rebound next year, and it really has started taking off for us. The three founders from our company go back all the way to the mid 80s. They founded a company called Deneb Robotics. Deneb was then bought out by Dassault and rebranded as Delmia. This isn't something that our guys, looked around one day and said, "Oh, let's try this." They were the founders. They kind of started a lot of the simulation practices when it comes to putting stuff in a digital space. And these guys are all currently with the company still today. When you take a look at our offices, we've obviously got the headquarters in Finland. We've got the office in Germany. Well, I'm in Detroit. Our headquarters is in Indianapolis, and then we've got a couple other direct sellers. And then, of course, a partner network, using their experience and their knowledge of industry and their understanding of process to work with Visual Components to really reach as many people as we can. The question always comes up: who uses your software? What does that look like? Can you kind of point me in a direction? Are there people in similar industries that are successful using the tool? And the answer is absolutely. Customers all over, different industries. The other day, I actually sold a license to a car wash, and they wanted to simulate where the drying vents would go and the coverage of that forced air on the cars. So there's really no industry that we don't serve. And these are some examples of our existing customers. When it comes to simulation, it's not just let's do a project, let's look at a part of it, let's have a very limited scope. Simulation to us is pretty much a cradle to grave tool, from capturing concepts and ideas to running, like Chris said, some what if scenarios and doing that Monte Carlo, to really, digging down to the nitty gritty, and then backing up and expanding it to a whole plan. You see, some of what it does on the left-hand side, and then what it does on the right-hand side. It improves your hit rate. It improves your customer experience. It improves how you go to work. Chris was very correct in people that implement early on versus people that are reactive and try and fix it once it's a very costly mistake. So there's huge benefits all throughout the manufacturing process, and we want to be there to help you along the way. Now, when we engage people, it's not about having a neat tool. It's not about having fun, although it is neat and you do kind of have fun using it. It's about providing a value, providing a return on your investment. And like Chris said, not getting burned by another software that, looks great. It bells and whistles, but when you get down to it, it really isn't the right fit for you. When we engage, we usually ask about questions. We say, what is it you're hoping to achieve? What is it you're trying to do? And those bottom three answers, the validation, project timing is too long, and lack of speed and agility, are all things that the three most common answers we get regardless. We update it quarterly, but those are always the top three. It's not just you. Everybody struggles with this, and it is absolutely 100% what simulation is designed to resolve and help you overcome. Those are all service pain points. What it really comes down to is top line, bottom line, and cash. Are you growing? Are you being rewarded for your effort? And what does that balance sheet look like at the end of the day to hopefully not only keep you in business, but to continue to help you grow? For years and years and years, there was big companies that ate small companies. You know, you have the Microsoft model. But we've seen, you know, recently over the last maybe 10 years or so, it's not the big that eat the small, it's actually the fast that eat the slow. If you're not taking advantage of tools, if you're not leveraging that technology, if you're not looking for better ways to, you know, do the same old thing, you know, chances are your technical relevancy is coming to an end, and your ability to compete with others in the market who are taking advantage of those tools is going to come into question. Some of the results that we've seen from customers that have implemented simulation are a reduction in overall project costs, reduction in project development time. Instead of spending weeks with Excel sheets and PowerPoints and 2D CAD, they're able to build entire lines, entire processes in a day, or maybe a little bit more, and really not only evaluate it and have it and see it visually, but really start to collect the data in order to make data-driven decisions. I mean, think about how many meetings it takes you to get everybody on the same page. If you were able to do that visually with the simulation, show people exactly what you're thinking, if you could reduce, you know, the number of meetings you have, there could potentially be huge value in that. We've seen people reduce their footprint by optimizing placement and the actual need of machines. Production capacity increases basically across the board. And because our simulation tool allows you to use multiple resources and different varieties of resources, typically we're able to do line balancing and optimize those tasks that are being done by those resources. In order to get you where you want to be, there's 3 different products. We have our essentials level. It's basically out of the box. It's that quickly grab, drag, drop, and build. It's a visualization tool, but it does give you the ability to analyze. When you get into professional, you have the ability to create. You can actually take imported CAD geometry, add kinematics, functions, features, behaviors, properties, rules, and really, you know, customize it and bring your best practices into play and really make it reflect what it is you're dealing with on a day-to-day. In our premium level, you know, Chris had mentioned, you know, the digital twin, the virtual commissioning. We now have direct connections to the KUKA controllers, the FANUC controllers, WinMod, Simit, Beckoff. So, you know, from early on in an essentials level, we're capturing concept and idea to actual implementation, VR outputs where you can use it during potentially Kaizen events to introduce concepts to line workers for feedback and validation before installation. There's a product that will help you on your journey, and not only that, but it's a product that scales with you. You might not want to do a digital twin today, but if you want to do it next year, instead of, you know, starting the process over again, looking for an additional tool that actually plays nicely with what you already have, you know, it'd be nice to have something that really has an offering to meet all of your needs and keep everybody on that same page and improve that internal communication in a company between the different departments and different divisions. On the website, I kind of listed some of our customers earlier. These are all customers and partners that have actually supplied case studies. You can go ahead and feel free to look through those. Find one in an industry similar to yours, and we can go ahead and you know, review that, take a look at that, and see what those parallels are and if it will meet needs similar to yours. And that's on visualcomponents.com. Real quick, this is all I have. We're going to wrap it up. Thank you for listening to the business part of it. Again, I'm Director of Business Development. I have made this presentation available to CAD Micro. So if there's anything that you want to see or you'd like it, just reach out to them, and they'll be able to take care of you, no problem. Now, for the little bit more of the fun part, when it actually comes to simulation, this is our tool, and this is the interface. Our software is built on the concept, and if you look to the left-hand side of my screen, of having a pre-made component library. So if we want to take a look by manufacturer, and we want to take a look at those different components, we are robot neutral, we are CAD neutral. There's not much point in having a visualization tool if you're forced to say, I know it looks like this, but what it really means is this, right? The tool you use should never be your limiting factor. And that's one of the approaches we've used when we put our software together. If we take a look at, ABB, I've got 109 of those models, 84 Denzos, 135 Fanics. So there's really a lot in there. Everything in our library has been tested. It's built and modeled based on manufacturing specifications with supplied CAD data. Speeds, accelerations, decelerations, things like that are all based on those manufacturer specs, preventing you from doing anything in a simulation environment that you cannot do in the real world. Now, when it comes to importing CAD, this is an actual list of all of the different CAD formats we support directly. So SolidWorks, you'll notice we can directly import that SolidWorks files up through 21. And every time we release a new version in a new given year, usually we'll go ahead and update those to keep current with everybody in the market. I believe Google SketchUp is the only one I've come across that we don't support, but I don't believe they work well with anybody else out there. So what I've done here in this particular layout is I've gone ahead and imported a 2D CAD drawing. Okay, this could be a concept and a design. This could be existing process. This could be something you're working on. Whatever the scenario, you can actually have it in your 3D simulation environment and use it to build a simulation. So instead of paint by numbers, it's almost simulation by numbers, right? So when we zoom out and take a much larger look, it's going to end up being a little something like this, where you get a 100% realistic representation of that 2 dimensions, but now you've got it in 3D for that visualization and the ability to analyze that process. When we take a look at simulation, everybody says, wow, it's difficult, it's hard to use, it's complex, there's a lot of steps, a high level of expertise, and in the past you would have been right. You almost needed a computer science degree. It was not very flexible, and everything you needed to do kind of had to be custom. We've taken a lot of that right out of the equation. Our simulations are built on the concept of understanding your process, knowing your steps and orders of operation. If you know that, you can choose from drop-down menus how things happen throughout the simulation environment. You can begin to enter in your own values and numbers and really start to see the results of that simulation. In our environment, in this one, I'm going to pretend like this is a current state. Current state and a beginning of a process is a great way to understand what's going on. In the past, I've talked to customers that their idea of improvement and how to approach it is by sending somebody into a plant with a stopwatch and a clipboard, and they're taking notes, and and they're trying to understand what it looks like and how it works. And then it's their job to go and put all that information into an Excel sheet, try and make some sense out of it, and hopefully come up with a better solution or an alternative or a way to improve. And well, that it may work. I don't think that's the most efficient or the best way maybe to approach optimization or continuous improvement. In scenarios like this, right now we're looking at basically entirely manual resources with some workstations, some machines. They're actually doing the palletizing on the far side. It's really very simple to be able to put things like this in here and just add parameters and properties to this equipment. I mentioned it's done on a concept we call process modeling. And process modeling actually looks a little something like this. We define the processes. We take a look at each operation or place in the simulation where an event takes place. We use a drop-down menu right here to add exactly what that looks like. We assign variables. We can set conditions. We can assign values. We can do failure rates. We can do a lot of different things, and it's all drop down, right? We add that, we populate the list, and then once we're done doing that, we simply take the products and we put them in order. And it's, again, done very visually. Everybody can look at this and understand this. Even the people, sometimes signing off and writing the checks, rather than having to say, trust me on this, it'll work. You can actually say, look, here it is. We've tried it. We understand it. We know what's going to go on, and here it is in a very visual way of presentation. But the visuals are not the only thing that simulation offers. When you take a look at this, the statistics and the value in order to make data-driven decisions are a huge part of what we do. I'm running this simulation right now at about 20 times speed, and what we can do is we can actually gather statistics throughout the simulation. Now, these are things that have been identified as statistics that we want to track. 100% customizable, define the times how you want, and then look for those values. We can take a look at outputs, human utilization, station utilization, things like buffers. Do you have enough space? What's that dunnage look like? What's that, what do all of those things have in common, and how do they drive what that throughput's going to be? And we can track production, we can track utilization, we can track average jobs an hour and things like that. So you really not only have the visuals, but you have the data to back it up. These graphs and charts can actually be exported. The data in CSV or Excel format, and the charts can actually be also exported for the purpose of presentation. Once you take a look at this, once you understand that current state, once you understand all of the data at a macro level, you can start dialing down into individual stations and try and come up with ways to make your process better. Now, in this scenario, all we've done is we've taken two operators here, and we haven't eliminated them, but we've actually redeployed them. With labor issues and things happening, and it being a larger and larger issue in manufacturing, if you were able to take this process and not only improve this process, but have additional resources for additional processes, well, maybe now you're killing two birds with one stone, and it's all because you use simulation to make the right change at the right place. Now, if we run this, the process and the flow never change. This is actually the same flow, the same process, the same steps, the same order of operations that we saw the first time. The only difference is we've reassigned it from a human resource to an AGV. Notice in this layout, AGVs and people working side by side. There's a lot of tools out there that can do fleet management, but at the same time, they don't have the ability to show what that interaction with people in the same environment might look like. There's a lot of companies out there that do robotics and do it very, very well. But when you have robotics and people and AGVs and machines and palletizing and conveyors, well, then your options start to, not be able to handle, the width and breadth of manufacturing today. Now, if we take a look at this over, given amount of time, one AGV is a disaster. Your production ends up getting cut in about half, right? If you had taken a week through, the old methods of maybe, putting duct tape on the floor and walking around and pretending to be the AGV and seeing what that scenario might look like, or doing it with cardboard, you'd probably be like, okay, let's rethink the AGV thing and go in a different direction. The advantage simulation gives you is you're able to do something this easy. We're able to take this, copy it, and you see I'm doing this real time. I simply added another one. I'm going to go to the AGV controller and add the resource. I'll hit play, and now we can watch that same scenario, the same process, but now we have two AGVs instead of one. In this case, it took me about 15 seconds to figure that out. And I also will see that there's a 4% increase in production based on this. Okay. Now, one AGV wasn't good enough. Two AGVs is great. Now, logic might tell you, hey, you know what? 3 is going to be even better. So if we were to add a third one, we would go about 10 minutes into the simulation before those AGVs ended up in a traffic jam that they were unable to get out of based on their movement parameters. Automation and simulation isn't just about, throwing a robot or throwing an AGV at a problem. It's about finding the exact right amount and making the correct investment. The difference between 2 and 3 AGVs is kind of a big deal. So knowing that going in is going to allow you to not only optimize your process, but make the right investment for your scenario and your situation. We've taken a look at this front half of the simulation and we've improved it. There's no doubt about it. We're up about 4%. A lot of people, in continuous improvement, their goal is 5%. If they get 2-3%, that's still pretty good. But nowadays, if you're only getting 2 or 3%, you are losing a lot of money. Okay, so the ability to go through this and really attack every part of it, to not get tunnel vision, and to be able to understand everything on a macro scale is hugely valuable for those people that, again, want to take control of their own process and really not just hit a number, but continue to go above and beyond that for a absolutely 100% optimized process. Now that first half is great. We did some good things there, but what happens when we continue on our optimization path and our quest for a better process? Well, in this case, what we're going to do is we're going to add robotics. In this cell, what again, process didn't change, steps didn't change, flow didn't change. Everything still has to happen to the product in exactly the same way it happened before. The difference here is we've again assigned a different resource to the transports in between those steps. There are 0 taught robotic points in this simulation. Okay. A lot of times, again, people start to think, hey, if I'm going to do this offline, it's going to be tedious. There's going to be a lot of steps involved. There's going to be a lot of teaching and a lot of time and effort invested into something that may or may not work, right? And we recognize that, and we have gone to eliminate that. So in our process, all we do is we assign, again, those transports from, maybe the inbound conveyor. to each of the machines and then back. If that robot has the kinematics to actually be able to pick up that product with a defined TCP and can drop off the product at the designated location, the robot will do it all on its own. Now, when you're in that capture concept and idea phase, all of a sudden you're doing reach studies, you're doing collision avoidances potentially, you're doing shopping around to find that right model robot that's going to fit there, and you've done all of that without having to spend the time doing the offline program. The robot's going to do it because that's how it's built. Once you've won the job, once you've chosen the direction, once you're sure of the outcome, then Chris had mentioned before their offline programming capability, you are 100% able to go in, teach that robot all of the points offline, and then through post processors take those points, export them into that robot's language, and upload it into the controller. Now, there's going to be some touching up. The real world never matches the simulation world exactly. But again, you've saved all of that time getting started by being able to do a lot of that offline programming very early on in the process. So when we back this out and we take a look at this, we can actually run this, and I'll speed it up so we can see what that looks like. We've absolutely optimized our front end. And again, without teaching any robots, we were also able to look at the statistics we generated, and we were able to look at the utilization. Those last two layouts had 6 machines each, right? We needed extra machines because those people were slower than the robot, and they need a little bit of extra time to walk back and forth and do their job, and maybe they're palletizing, and maybe there's some backup. So they needed to have all of those extra machines in order to keep up with those production goals. In this case, where we have a robot doing the machine tending, we have actually increased the efficiency of all of those machines by having them service faster, and we've eliminated those machines. Again, if there's a CapEx buy, we avoid it. If there's an existing process, we can potentially, once again, just like the resources, we can redeploy. There's a lot of options, and again, we save floor space. And let's not kid ourselves, floor space is money. I've gone to been on site with customers where there's a hole in the back wall of their building. And I say, what happened there? And they're like, yeah, we designed a process, but nobody ever thought about if it was actually going to fit within the 4 walls of our facility. Nobody ever takes into account for a lot of these larger things when they're being built, structural limitations. So a lot of that, being able to do it in a 3D environment and to see it and to understand it, really does go a long way when it comes to making the right decisions. This is a very visual tool. And again, we grab those statistics, we understand all of those values, the stations, the outputs. We can start to track OEE utilizations, operator utilizations, all of the different parts of the simulation. When it comes to being done and wanting to take that next step and share our idea, again, this is a visual medium, so we've actually built a lot of tools into the software to let you be able to take advantage of what it is you're seeing on the screen. And it's done just this easy. I'll reset this to run in real time, but there's this little V up in the corner of my toolbar. All I have to do is click on this and say, you know what, I want to start recording the simulation. Now what this is going to do, demo, what this is going to do is create an animation file. This animation file is used in 2 ways. One is it's used in a virtual reality environment, okay? If you have the gear, there's a very simple, very free application on the website and in the Google Play Store and in the Apple Store. It's called the Visual Components Experience. What it allows you to do is take this animation recording and, like I had mentioned before, put it in virtual reality. You can walk this line. You can stand at these stations. You can understand exactly what that process looks like in a scale environment and understand, what's going on in a way that 2-dimension, even 3-dimension on a screen simply won't let you do. Okay. I stopped recording it, and I'm going to click on the little icon that showed up. We see visual components experience. Once again, in those two options, the other option is to use the experience as a viewer. So if we click that we want to open that up in 3D, the experience will open. And what's going to happen is this exact layout that we're seeing comes up. Now, I am zooming, panning, tilting, rotating, going through all of the parts of this simulation as it's running. This is something that if I had to guess, and I'm not going to guess, I'm just going to tell you, this is the file I just saved. This is a 2 meg file. This is an email attachment. This is something that is very shareable. This is something that after you've captured that concept and idea, allows everybody to get on that same page very, very quickly, and then make the most use of meetings and decisions, and get you to your solution faster and more efficiently than potentially the method you're using now. In addition to the experience in the animation files, Visual Components has the ability to generate 3D PDFs, AVIs, MP4s. You can do high def screenshots directly from the software. You can export 2D, so you can do DWG and DXF files. There's no sense in building it in 3D if you have to redo it when you move to 2D. So we've again shortened a lot of those steps by providing tools that allows you to go back and forth from one world to the next. We even have a tool, an external rendering software that we've created an application for, where you can do rendering directly out of our software. So if you wanted to make that presentation, if you wanted to, spice it up, we have customers that actually use this for marketing. And I will go ahead and show you some of these renders real quick, just so you get an idea. Let me move this over. This is, again, capabilities that you're going to find in Visual Components. This is, what it would look like if you go through this. And again, it's coming up on my other screen, so sorry about that. But let's go to some of these. If you really wanted to make some materials, if you wanted to show what it is you do and really put that stamp on it and make it look professional, this software has the ability to really, really up your game. Again, cradle to grave, concepts and ideas, applications, offline programming, controls validation, marketing, Kaizen events in the VR, and selling your solutions that way, or proving your solutions that way. Simulation is really a tool that you can leverage, that you can take advantage of, that everybody within an organization can use in order to make your process better. Now, we've taken, I don't know, the last 25, 30 minutes to kind of go over the software at a very, very high level. Cover some of the basics, cover some of the ability from a micro to a macro level to deal with simulation. Does anybody have any questions that we can address right now as it relates to simulation and some of the things that you've seen? If you do, I'd be more than happy to address those now. If not, I'll just grab one more layout as we're looking to kind of show you the scale of simulation, and that it's not even limited by your four walls. That simulation goes beyond that. That simulation fills a lot of other issues, be it supply chain, be it delivery, be it maybe shipping and receiving is a bottleneck. It really does just about any and everything that you could ask it to. So if anybody has any questions, I would be happy to answer those now. We'll take a look at this last larger scale simulation, and then we'll go ahead and wrap it up.
We do have a question that's in the queue, and it is, what part of the manufacturing process is the best to start using simulation?
Well, again, I think that when it comes to simulation, if you said, I want to do digital twin tomorrow, I would probably say that's not where you want to do it. The idea of simulation is to understand your current state, is to understand what you have going on, right then and there and now, and what's in your face. Instead of guessing, simulation again allows you from very early on in the process to design things better, to come up with better scenarios and systems. All of that other stuff, the digital twin, the offline programming, that all comes later on. That's a byproduct of what simulation can actually deliver to you if you truly understand your process. If you don't understand what's going on and you just start throwing robots and throwing AGVs in there, you got the potential to do more harm than good. Use it to understand what you've got, use it as a basis, and build all of your other steps based on having a good understanding and a good simulation of your process. That's I would start with simulation at the very beginning. Don't try and skip to the end. Get good at the basics and have a tool that scales with your needs and your goals.
Awesome, thanks, Graham. We do have another question that is more so about the software, and it is, how long does the software take to learn, and what kind of computer do I need to run the software?
Okay. Great questions. Again, based on people's perception of simulation in the past. The learning curve on this, because it is process-based, is very short. The simulations I showed you earlier, where there's multiple processes, there's lines, there's cranes, there's robots, there's people. After training, I would expect anybody to be able to put together a simulation very similar to that in a day. And you just get better as you use it more and become more familiar with the interface and the capabilities. But again, as long as you know your steps, as long as you have that concept, as long as you understand your world, and assuming that you're the expert, it's very, very easy to pick up, because it is all drop down menus and becomes very intuitive. When it comes to a computer to run this, back in the day, you had to buy hardware to go with the software, and those days are long gone. Basically any system, if you're running SolidWorks, you can run visual component simulation. My recommendation is to have an outstanding video card, but outside of having a good video card, again, we run our experience on a phone, so it's not necessary to make a big purchase of hardware to go along with your software.
Amazing, thanks. And then there's one last question that came through, and it is, how often is the software and library updated?
Okay, another really good question. As long as you have maintenance on the software and it's valid, we update the library constantly. It's our job and our goal to put as many pieces of equipment, as many models, and provide as much functionality as possible. While we update multiple times a week, the second we add it to our library and hit save, you have access to those components. And then quarterly we'll publish a big wrap up of everything that's been added that quarter, and usually there's hundreds of components every quarter that are added. Again, it's hard for us to have everything. We do a lot of it on request, and we'd like to just keep adding as much as humanly possible. When it comes to the software, we've been doing about one major version upgrade every year. As long as, again, you have maintenance on that software, as long as you're current, all of those major version upgrades with all of the enhancements to process and functionality and new things that we're constantly adding in is 100% free. So, that once a year you would simply send in a request and say, hey, I'd like the latest and greatest, the biggest and best. And we say, hey, that we're happy to help you out. We send you out that new key and you're ready to rock and roll. So the upgrade process is free. It's very easy. And again, as we add those tools, it keeps you relevant, keeps you efficient, and keeps you on the cutting edge of what simulation allows you to do.
Great. Thank you, Graham.
If there's any additional questions, I can answer those. If not, like it was mentioned earlier, you can feel free to send your questions in, and I'll be more than happy to help answer anything that comes through.
That looks like it is all for questions at the moment. So I guess that is all that we have time for today. Like Graham had mentioned, if any questions do arise after we finish here, please do not hesitate to reach out to your account manager or reply to the webinar email and we'll be in touch. Thank you so much for a great presentation, Graham and Chris, and thank you all for joining us here this afternoon. We hope to see you again soon. Thank you.